Welcome to 3.3 matrices and their operations. Today we're going to write a matrix and perform addition subtraction of matrices. So the first thing, what is a matrix? It's a rectangular array of values in rows and columns. And the dimensions are written as m by n, where m is going to represent rows, which are horizontal, and n is going to represent columns, which are vertical. So matrix are written with a capital letter as their symbol. So capital A is equal to this matrix. This is matrix A. Now the dimensions are the number of rows. I have 1, 2, 3. And the number of columns. I have 1, 2, 3, 4. So the dimensions of matrix A is 3 by 4. What is the entry at A? And we always notate entries as a lowercase letter so you know what matrix you are referring to. So lowercase a, 3, 2. This is going to tell me that I am looking at row 3, column 2. So when I go to row 3, column 2, I get A32 is equal to 2. And what is the address of the entry 8? So when I look at 8, it is in the first row, the third column. I'm going to notate that by a lowercase a, 1, 3. The primary function of matrices is to simplify how we look at systems of equations. So we're going to be converting from systems of equations to matrices. It basically is taking away the fluff of the equation. So what I want you to first notice is that when I look at my first system, I'm going to have two different equations. These are going to represent how many rows are in our matrix. And we get our columns from how many variables are there. We have variable x, we have variable y, and we have our answer. So what I'm going to do is I'm going to format my matrix to look similar to my system of equations. I'm going to have a column for my x coefficients, a column for my y coefficients, and a column for my answers. Typically, you'll see a line that is separating the um, variables from the answers. And then all you're going to do is you're going to pull the coefficients out. So looking at equation 1, my coefficients are 5, 6, and my answer is negative 10. So I'm going to fill that in. 5, 6, negative 10. For my second equation, my coefficients are negative 3, 8, and my answer is 15. So I get negative 3, 8, and my answer is 15. So now we've converted to a matrix. What you have to be careful of, sometimes your equations are not set up nicely. You want to make sure that you have everything organized. So I went ahead and rewrote some of these equations. So I have 5x. Notice that there's no y variable, so I have 0y plus c equals 12. Then I have x. I subtracted 2y to the other side and added z to the other side equals 8. And then I have 0x plus y minus 2z equals 12. Now, you don't have to have these 0 variables there if you remember that zeros belong there. I'm writing it there for the sake of us remembering together. Notice that I have 1, 2, 3 equations, so I'm going to have 3 rows, and I have 1 variable, 2 variables, 3 variables, and then my answers. So I'm going to set up my matrix to look similar to this. X, Y, Z answers. Then from my first equation, I get 5, 0, 1, 12. From my second equation, I get 1, negative 2, 1, 8. And then I get 0, 1, negative 2, 12. Be super careful when your equations are all mixed up like this. You want to make sure they are in order, otherwise your matrix is wrong. For example 3, we are going to convert from a matrix to a system of equations. So remember, I am going to have equations based on my rows, so I should end up with 3 equations. And it's looking like I have 3 variables and my answers. So I'm just going to go through and rewrite these out. So 4x plus 2y minus z is going to equal 8. Let's see. There we go. And then I'm going to have no x variable. You could write 0x, or you can just start with y plus 2z equals 10. And then we have no x variable, no y variable, but I do have z equals 4 as my last equation. Something that becomes a big part of the next lesson is adding and subtracting matrices. So to add or subtract matrices, they must have the exact same dimensions, exact same number of rows, exact same number of columns. They cannot be different. And to multiply a matrix by a scale factor, all you have to do is take the number written in front and distribute it, multiply that scale factor to every entry in your matrix. So let's go ahead and look at example 4. Example 4 says to use the matrices below to perform each operation. Let's go ahead and identify the dimensions first so that we're working smarter, not harder. So I have 2 rows, 2 columns. So this is a 2 by 2. For matrix B, I have 2 rows, 3 columns. So this is a 2 by 3. For matrix C, I have 2 rows, 2 columns, 2 by 2. And for matrix D, I have 2 rows, 3 columns, a 2 by 3. Now let's get to adding and subtracting. I'm going to add matrix A to matrix C. So that's matrix A plus matrix C. So when I'm adding these two together, they do have the same dimensions. Now, why this is important is at every entry, we are going to perform the addition operation. So I'm going to take 7 plus 1, 8 plus 4, -2 plus 8, and -4 plus -3. That's why it is so important to have the same exact dimensions. So when I perform this algebra, I get a plus c is equal to 8, 12, 6, -7. For D minus B, I'm going to set it up first. I have matrix D minus matrix B. They have the same dimensions, so I can move on. So I'm going to get all of the entries are being subtracted from each other. When I simplify, be very careful with subtracting a negative number. Remember that turns into addition. I'm going to get 3, 0, -9, 6, -1, 1. Now, when I apply a scalar, so I am doing 2a plus c. So first thing I'm going to do is write out my equation to verify that I have the same dimensions, and I do. When applying a scalar, this 2 is just going to distribute to every single entry. So 2 times 7 is 14. 2 times 8 is 16. 2 times -2 is -4, and 2 times -4 is -8. And then once you're done with that, it's the same process. I'm going to add the entries together that are in the same position. So my 14 and my 1, my -4 and my 8, and so on. So I get 2a plus c is equal to 15, 20, 4, -11. Now for D, I'm going to write out my equation, and I notice that I have a 2 by 3 and a 2 by 2. When I am adding or subtracting, it is so important that you have the same dimensions, and I don't. So when my dimensions do not match, I have a mismatch, there is no solution. You cannot do this problem.